All right, so we're going to wrap up solving absolute value equations with just another couple of examples here that might involve having absolute value on both sides. And it's not terribly different, although a couple things could happen. So let me start before we go back up to the general setup here. It could be that, and let's just always be on the lookout for, suppose I had absolute value of x over 10 minus 4 is equal to absolute value of negative 10. So the first thing I want to say is be on the lookout for situations when you can actually evaluate the absolute value, because here the absolute value of negative 10, that's just a number. That's just 10. So first thing, don't overcomplicate something that can just be simplified, right? I mean, one of our kind of fundamental steps to equation solving in general is simplify each side first. And so if there is an absolute value that can be simplified, do that simplifying first. All right, so now that we've actually evaluated that and we have the absolute value of negative 10 here is equal to 10, now we just have the setup from the last video. Okay, this is the usual setup. So what we look at is that absolute value of a quantity is equal to 10 if the inside, so if x over 10 minus 4 is equal to negative 10, or if that inside, x over 10 minus 4, is equal to 10. So now it's just like, so I'll just even say here, now we have something that's like last time. All right, so let's solve these equations. So adding 4 to both sides on both equations, and we now have x over 10 equals negative 6, and x over 10 equals 14. And then our last step to solve for x, right now it's being divided by 10, so we're going to do the opposite and multiply both sides by 10. And so we get our two solutions, x equals negative 60 or x equals 140. Okay, so be on the lookout for ones that maybe are just absolute values that can actually be evaluated if it's all numbers. All right, but then the question is, well, what if it's not and there's two absolute value bars on each side? So suppose we have absolute value of negative 3x minus 1 is equal to the absolute value of 4x plus 5. I think that maybe your instinct might serve you well here, because you would probably just try to do something similar that you did before. So what I want you to think about, so now we're going to go back up to, so I'll say this implies by star up here. So if you have two quantities, let's say a y and a z, even just two numbers that are equal in absolute value, so they are the same after you take their absolute value. So how can you have two numbers that are the same after you take their absolute value? Well, there's two ways that could be true. They could have been the same to begin with. So if they're the same, then the absolute value bars of them, so if two numbers are equal, their absolute values are equal. The other could be that one's positive and one's negative, but then when you take the absolute value, they're the same. So we say that as one of them could equal the opposite, so the opposite, there's my negative right there, and then these parentheses are going to be super important if there's more than one term, which we're going to have, if one is equal to the opposite of the other. So again, if one's 5 and one's negative 5, if you take their absolute value, they're equal. So if two quantities are equal in absolute value, that means they were either equal to start or they were opposites. All right, so we are going to follow that setup, which is going to tell us that, okay, these insides could either be equal, so we could start off by saying the insides themselves, negative 3x minus 1, could equal the 4x plus 5. So we're just setting and saying if they are equal, then their absolute values are equal. Or it could be that one of them, let's say negative 3x minus 1, that's like the y. So we're taking the inside of one of them, negative 3x minus 1, could be the opposite. So could be the opposite result of the other one, which is the 4x plus 5. So they could either be the same or they could be opposites. So kind of like what we do in the general case, you set one equal to the positive and one equal to the negative. It has a very similar feel, but it's just a slightly different logic on this one. All right, now we have two equations out of absolute value bars, so now we can just solve them. All right, so the one thing we do need to take care of first before we get too far, let's make sure we realize on the second equation here, and this is why those parentheses were just so important, is we do need to distribute through that negative. So this is really going to be negative 4x minus 5. All right, so in solving the first equation, it's up to you. You can, if you want, if you like the idea of getting the 4x on the left, you can subtract your 4x. Maybe at the same time, if we can also think about how that's going to give you the negative 7x on the left, maybe at the same time, you can think about also adding 1 to the right-hand side. So if you can kind of do both of those together, it might be helpful. A little shorter. Equals then 6. And our last step here, to solve for x, we would want to divide both sides by that negative 7. So we get that one of our solutions is going to be negative 6/7. All right, on the second equation here, maybe I add my 4x. I like the look of that one because that's just going to give me an x on the left. That'll be nice. And so maybe at the same time, we can go ahead and also just add the 1 over to the right. And so when we do that, we are going to have x equals negative 4. So that's actually already done. So there's our two solutions on that one. All right, so that's the last little piece there of solving absolute value equations. When we come back next time in section 9.3, we are going to look at solving of absolute value inequalities.